Hello and welcome to ESA's Afternoon Technology Series, where today we will be going over using MSC APEX for model cleanup. My name is Austin Pizzella. I am a product development engineer at ESA, and I will be showing you how we at ESA utilize APEX to quickly repair solid model geometry. You can reach me at austin.pizzella@esacorp.com. APEX Modeler is a part of MSC's new APEX suite of software and includes APEX Modeler, which we will be covering today, and APEX Structures, which is yet to be released. APEX Modeler allows analysts to pre-process geometry, and APEX Structures will allow analyses to be performed entirely within the APEX suite. More information is available on mscapex.com. The focus of this presentation is solid model geometry. MSC has already released several webinars on 2D modeling, so we wanted to demonstrate what is possible with 3D geometry using APEX. A little background on ESA. ESA was founded in 1991 when Martin Martinez received a call from a small company called Intel to help them solve a structural thermal problem on the production line for the 486 processor. As a small business, aside from supporting companies such as the ones you all work for, we also have landed government research and development contracts and hold the following certifications. Here at ESA, we provide engineering solutions and technology to our clients. We help larger companies with on-demand expertise and smaller companies with product development, prototyping, and testing. We are also an MSC channel partner, which enables us to provide you with software solutions, including implementation as well as training. ESA prides itself on using proven product development processes that are successfully used in industry, which allows us to provide on-time solutions. So how does APEX Modeler fit into the current analysis process? First, you begin with your model geometry. APEX accepts native file types such as those from NX, SOLIDWORKS, and CATIA, and also neutral file types such as IGEST, Parasol, and STEP. Once you have your geometry in APEX, you can either make changes to your model geometry and simply export as a Parasol file through a preprocessor such as MSC Patran or ANSYS, or you can also mesh your edited geometry and export both a bulk data file and edited geometry. In your preprocessor, you can apply loads and boundary conditions and then solve your model. Once APEX Structures is released, the entire process of geometry manipulation, meshing, solving, and post-processing can all be completed within APEX. For our first case we're going to look at today, case 1, we have a turbine blade. And this turbine blade model that we're looking at here is a 30-degree cyclic symmetric slice of a entire turbine wheel, and essentially this 30-degree slice captures a single turbine blade of this wheel. So essentially, to imagine the entire turbine wheel, you take this 30-degree slice and revolve it 360 degrees around. So you have a turbine wheel that has 6 blades on it. This model has 2 problems. First, on the leading edge of the blade, you have these very small faces that run almost the entire length of the leading edge. And what happens is when you bring this into your preprocessor to mesh, your mesher is going to mesh those small faces, and you're going to get very small, likely very poor element quality in those faces there, as you can see with this example. Also, on the back side of the turbine wheel, we have a very small face that runs the entire diameter of the turbine wheel, and once again you're going to get very small elements on that face. That's likely going to lead to geometry issues. So let's go ahead and open up that model in APEX. And I already have the model open, and this is simply a Parasol file that I imported. We can see that, take a quick look at our turbine blade. And in our model tree, we see that we have a solid body. We'll come back to that a little bit later. So if I had no background on this part, it may be very difficult, and in some cases extremely difficult, to find these very small features that I showed in that presentation slide. So there's a tool we like to use under the geometry edit tools called Geometry Cleanup. And the purpose of this tool is actually to automatically remove features that you select from this drop down here. However, we're going to use it to find problem areas. And I have already selected sliver surfaces with a width of 0.01 inches. Just for the purposes of this presentation, you could also look for small edges, small faces, etc. So what I need to do is click on our solid body, click Preview, and Apex has found several issues with our part, several sliver faces, or sliver surfaces, excuse me. So let's click on this first one, and we can see that Apex is showing us that small face on the back side of that turbine wheel. I can also click Auto Zoom to selected entity, get a better view. Click on the second problem. Apex zooms us in. Let's zoom out a little bit actually. And Apex is showing us those very small sliver surfaces on the leading edge of the blade. See how small these surfaces really get. We can just imagine the problems the mesher is going to encounter when trying to mesh these. Okay, so as I mentioned, this tool is created to automatically correct issues. However, we're going to show how you can manually fix problems today. So let's go ahead and close out of this tool. Go ahead and zoom out. To take full advantage of all the tools that Apex has for model cleanup, we're going to have to turn our solid body into a surface. And to do that, we need to go ahead and just delete one of the surfaces, one of these solid faces that we have here. And the face that we delete, we want to be nice and uniform. We don't want to take any or select any faces that could possibly be hard to fill in once we're done making all of our corrections. So for instance, we wouldn't want to select this face as our face to delete. It's a little bit too complex. This face right up here is probably the best candidate that we have. So all I need to do is simply click on that face. I'm going to hit delete on my keyboard. And Apex is going to say, deleting this face will turn the solid into a sheet body. Do you wish to continue? And of course I do, so I'm going to click yes. And we can see that my solid body is now a surface body under our model tree here. So it's also a good practice to go ahead and make sure that this face that I deleted can easily be filled back in once I'm already done making all my model corrections. So to do that, we need to go to our geometry edit tools, select the filler tool, and see that Apex has highlighted the boundary of that face with red lines or red edges. And that's basically just telling us that we have a gap in our geometry there. Something's wrong. So I can just click on one of those edges, and we can see that those red lines are now gone, and now we have green thick lines indicating a solid body everywhere. We can also see back on our model tree that we no longer have a surface, we have a solid body. So that face is indeed easily filled back in once we're done. So I can just go ahead and click on the back button, and now we are back to a surface body. I'm going to go ahead and close out the filler tool. Okay. So let's go ahead and begin with the leading edge of the blade. Zoom in a little bit. Okay. So we're going to use the vertex edge drag tool to do most of our work today. And all I need to do is zoom in a little bit more and just select this vertex here, simply drag it to this other vertex. Okay, you can see that that face is almost closed up. Now what we need to do is take this vertex down here, drag it over. Okay, and that face is now gone now. Go ahead and close out of this tool. We saw that we have an extra vertex on this line here that was left over. We don't need that for our purposes. If anything, we're just going to get an extra element edge along this larger edge here. So let's go ahead and just delete it. See that Apex went ahead and deleted the vertex and straightened up that curve there too. Close out of this tool. Get back into our vertex edge drag. And let's go up our edge a little bit. So what I'm going to do here is take this vertex and just drag it down. Okay. Zoom out, rotate around. Take this vertex, bring it up. Okay. And then to finish up this area, I just need to take this vertex, drag it over. Okay. And then by zooming out real quick, we can see that we no longer have any of those very small faces in there. There's just a few things that we'd like to clean up that aren't totally necessary, but are probably good to go ahead and do it anyway while we're here. So let's select this vertex, drag it up. Okay. And one. Okay. And we also see that we have these vertices on this side, and there's also one on the other side of the blade here that don't really serve a purpose. And actually, they're going to get in our way a bit. When our mesher comes in here, it's going to want to put an element edge right here on this geometry edge. So let's go ahead and drag this over. Okay. Rotate to the other side. Drag this one over as well. Okay, let's go ahead and finish up the leading edge. And I'd like to go ahead and preserve this edge that we have here that's actually on the face of the turbine wheel. So we're going to take this vertex and drag it over to there. Okay, and we can see in just a few easy steps, we no longer have any of those very small faces that we had. We now have fairly large faces for our mesher to go ahead and mesh, and we should be able to get a pretty nice mesh all along on this leading edge here now. Go ahead and close out of the vertex drag tool, and we can go ahead and use our filler tool and fill back in that top face. We can see that now we're back to a solid. Now that we're back to a solid, I didn't forget about that small face on the back side of the turbine wheel. But since it's a fairly simple face to fix, we can easily use the defeature tool. And we just need to select face. Yeah, select that face, okay. And we can see that Apex went ahead and cleaned up that face there. You can also use the defeature tool on features such as fillets that you don't want. Say the customer no longer wanted a fillet on this body here. We can just go ahead and click on that fillet, and Apex goes in and deletes it. We're going to go ahead and keep it for our purposes. So now I'd like to show how we can mesh in Apex and then export that mesh into Patran and use it as a seed to mesh this entire solid body. Okay, and just for a simple example, we're going to mesh just a few of the faces on this leading edge here. So I'm going to go to Meshing, Surface Mesh. Going to go ahead and stick with 6/1000 of an inch for our mesh size. Going to use triangle elements for our mesh type, map mesh, and quadratic elements. Okay. Go ahead and select face as well as this one. Close out a surface mesh tool. I can also just quickly hide our geometry to get a better look at our mesh. So this is much better than what we would have gotten with those small sliver faces in there. Now with those faces gone, we get a nice uniform mesh, get a very nice matte mesh actually on those two faces. So I'm going to go ahead and just mesh those two faces for this example. And to export into BDF and also a Parasol, all I need to do is go to my model tree, right click on mesh 1, and go to export. Let's call this leading edge mesh. Apex is going to ask me for a unit system. I'm going to select custom units, which I had previously set up, and click export. And Apex is going to give me a warning that because I have chosen custom, the custom unit system, my units may not necessarily be consistent with one another. However, I have verified my units are all consistent. I don't have inches with kilograms, etc. So it's just giving you a warning saying that this could cause problems if you had inconsistent units when the Nastran solver goes to solve. So I'm going to go ahead and export. Like I said, I've already verified that everything is correct. Get my Parasolid of my edited geometry, I need to right click on solid 1. Go to export. I call this Turbine Blade Apex Edit. Click export. Okay. Now let's go ahead and open up Patran. Going to go to File, Import. Bring in our Turbine Blade Apex Edit. Going to get an import summary from Patran. Click OK. Zoom in here quickly and verify that our changes were made. And we can see that those small faces that we began with are no longer there, so we do have our edited geometry in Patran. Go ahead and zoom out. Bring in our mesh. Go back to File, Import. I'm going to change our source to MSC Nastran Input. I'm going to select Leading Edge Mesh. Get a little warning. I'm going to click Yes. And we can see that Patran brought in 297 nodes and 130 elements. Yes. Okay. So Patran has no knowledge that this mesh and these elements are associated with those faces on that solid geometry. So we need to go ahead and reassociate them in Patran if we want to do any manipulation here. We're going to go to Meshing. Going to go to Create, associate element with surface. Go ahead and select all of our elements. We're going to turn on visible entities only, make selecting those solid faces easier. Click apply. Okay. Clear everything out. Those elements now should belong to those solid faces, and to verify that, we can go to Tools, List, Create, change our object to element, and our method to association. Then I can select those solid faces again. Click Apply, Highlight. And it does indeed look like all of our elements are associated properly to those faces. Now that they are, we can go ahead and use them as a seed and mesh the entire solid body. Let's go to Create, Mesh on Solid. Let's actually do 0.01 for our mesh size. Give Patran a second to mesh. And we can see that Patran did properly use our seed, our shell seed, to mesh the faces of that leading edge exactly as we wanted, and then it finished and meshed the entire surface or the solid body. So the route that I showed where we manually made the changes to the solid geometry, exported the both the BDF and as well as the edited Parasol is a good process to follow if you wanted to use the association of any of these faces to apply loads. Say that I have loads applied to this face here, or even these faces here for my cyclic symmetric MPC equations. It'd be very nice to be able to just click on those faces and get the nodes associated with them to apply loads and boundary conditions. There is another method that I'm about to show you that you can use where you can make geometry changes more quickly in Apex. However, you're going to lose that associativity in Patran if you needed to easily select faces to apply loads and boundary conditions. Let's go back into Apex. So I can easily go back all the way to where I started from by just clicking the undo button. I'm going to have to click it quite a few times here. I can go all the way back to where we started. Okay, back to where we started with. We're now at a solid 1. And we can see we have all of those small faces on our leading edge. So we definitely are back to where we started from. So let's say I don't care about having my geometry associated in my mesh. I just need a mesh to bring into Patran to apply loads and boundary conditions. And I can do that easily without having to select any faces to find nodes associated to it. So what I could do is I can go to Geometry Edit, Suppress, Unsuppress, and I can just click on any of these edges. And I'm telling Apex to go ahead and suppress them, ignore them for the purposes of meshing. So I've selected all of these purple lines. I can go ahead and close out the tool now. And we can see that Apex is showing me those those lines are no longer there. However, if I was to export this model as a parasolid, those edges would still actually be there, and I could not easily associate a mesh that I created in Apex with that solid model geometry, because now I have too many faces. My edge and element edge definitions aren't going to line up properly. But as I mentioned, if we want to do all of our meshing entirely in Apex and bring over a mesh and no geometry, this is a very quick and simple way of making changes to my model. Because now I can just click on this face here on the leading edge, and I can get a mesh on there. We can see those. It's totally ignoring those geometry edges that were actually in the model a few seconds ago. Okay, so let's go ahead and mesh this entire body. We're going to do 0.01 for our mesh size again, and just use all of the default settings that Apex recommends. Okay. See that those geometry edges are still being ignored for our solid mesh. We can go and zoom out. Okay. And we get a pretty nice looking mesh. Just using the default settings, we see that Apex recognizes our fillet here as a fillet and applies a nice uniform mesh along that. And although we even have our mesh already on our body here, we can still make changes very quickly to our geometry. For instance, if I wanted to make this face here a certain height higher, I can use the PushPull Tool. Select that face and even just pull it up an arbitrary length. Give Apex a second to remesh, and we can see that that change is now made. I could also go ahead and defeature that fillet again. Let's say the customer changed their mind, they actually do want that fillet gone. Click on that fillet. And the fillet is no longer there, without even having to remove my mesh and remesh the entire solid body. Okay, so that wraps things up for the turbine blade. Go ahead and gonna hide our part here. Go back to our presentation. So case 2 we're gonna look at is a pump housing. So once again, we have a similar problem to where we were with the turbine blade. Not quite as severe on this case, however, we still have many faces that terminate at small angles where we're going to get poor elements, and we don't need all of these faces to represent this portion of our fillet, both in these two areas here. Because it's so easy to make geometry changes, we're going to go ahead and make those changes real quick in Apex here. Go into Apex. Go ahead and hide our turbine blade. Okay. So this is our slice of our pump housing. And the first thing we're going to go ahead and do is we're going to change the color from this greenish color to something a little easier to see. So I can easily just click on that green square, which represents the color of the part. And we can select a number of colors from the color palette. Choose this dark gray. And that makes things easy when you're reporting things to a customer or even showing things in a presentation. You can easily, if you have multiple bodies in assembly, you can easily color things differently as you please. You can select different colors for any number of bodies. Okay, and so our first step that we're going to have to make when we're cleaning this up is we're going to need to go ahead and select a face to delete, as I showed in the previous example. Not too many great candidates here. You can go ahead and use this space though. I'm going to press delete again. Apex is going to warn me, and I'm going to say yes. Okay, and we see that our solid body is now a surface. Just to test once again, we're going to go to filler. Okay, so that is the face that we're going to use. Alright. Go ahead and zoom in on this region. This is the first area we're going to take a look at. And once again, I'm going to go to my vertex drag tool. I'm going to take this vertex here, drag it over. Do the same with this one. Okay. Now we can see that we have, instead of 4 or 5 faces, now we just have 2 faces representing this area. We can actually get it down to 1 very easily. Go ahead and close out of our vertex drag tool. I'm going to change my filter, and I'm simply doing this by using the keys on my keyboard. We can see the arrow keys on the keyboard. We can see that I'm changing the filter by simply using the left or right arrows to select either the vertex, edge, or face filter tool. I'm going to select the face filter tool. Select these faces. Press delete. Press delete. Go ahead and use the filler tool. And select one of these edges. And we can see that our fillet is now complete. And we are going to get a much better mesh now without all of those faces representing this small area. Okay, we can now close out of the filler tool. Let's take a look at the back side. And on the back side we have much of the same situation. Okay. Go back to the geometry edit. Vertex edge drag. Take this vertex. Okay. Drag this down. Follow this. And we can see we have another hanging vertex here. Let's go ahead and just get rid of that using the Add Remove Vertex tool. Okay. That edge is now, we now have a single edge where we used to have 2 edges here. Now with this, I can also select both of the faces, delete them, and fill them in. Another approach I could take is to use the Add Remove Vertex tool, which I already have open, and simply add a vertex right near the center of that edge. And we can also see that we now have 2 edges. I can then use my vertex edge drag tool and simply drag that vertex down here. And we now have clean geometry. So to finish up, we just need to fill back in that surface. Thick lines show us that we have a solid body once again. And we are now done with the pump housing. to our PowerPoint. Our third and final case, we're going to be taking a look at a transmission housing. And once again, with the other two cases, we have a small face. However, this is just a single small face that runs the entire, almost the entire length of this part. It begins up here at a very small angle and then runs down the entire length of this transmission housing up to the opposite side. And once again, we're going to get very small elements in these areas, which are going to lead to distorted geometry. So we're going to go ahead and open that up and correct it in Apex. Okay, let's just take a quick look at the problem. So we can see that it's this face right here, that's the issue. And it starts at that very small angle and leads all the way down. Let's actually zoom out a little bit. Runs all the way down to the opposite side. And this is about 0.02 of an inch, and this entire part is about 11 inches, or almost 12 inches in length at its longest point. So this is a very small feature in comparison to the rest of the body. Go ahead and fix it up. So once again, we need to find a nice uniform face. And it looks like one of these two faces here would probably be the best candidate. Go ahead and select this back face. Delete. Yes. That face is so uniform that we really don't even need to try to do a practice fill just to test it out. I can tell that it's already going to be easily filled in by Apex. So our first step, go ahead and delete some faces. Go ahead and delete this fillet, as well as face. Okay. Take a look at that left corner. Let's go ahead and use our Add Remove Vertex tool. Zoom in a little bit. Go ahead and add a vertex on this line edge here. Okay. Then we can close out of that tool. Open our vertex drag tool. Go ahead and take one and drag it down. Okay, we can see that Apex went ahead and cleaned that up. It knew that those two vertices were so close together that it went ahead and joined them for us. Now we need to clean up the back side, or rather the other side. And for this one, we can simply select that vertex and drag it down. Have it. Okay. Go ahead and zoom out. Okay, now that's all left to do is go ahead and fill in that fillet with our filler tool. Okay, now we see we have our fillet back in the model. Fill in that back face. Close out of our filler tool. Okay, and before we go ahead and mesh this, go ahead and run our Geometry Cleanup tool and just check for any other small features. And instead of sliver surfaces, let's go ahead and look for small faces. Again, I'm going to use 0.01 for my tolerance. I'm going to select our body. Click Preview. See that it found one problem. Go ahead and just zoom in a little bit. And it looks like we have a little knife edge in our model, essentially. I mean, it almost looks like it's a single edge that doesn't belong there. Go ahead and take a closer look. Close out. Use wireframe. And we do indeed have a knife edge in our model. Let's go ahead and turn our solid geometry back into a surface. Use our vertex edge drag. Turn wireframe back on. Zoom in. Drag this vertex up. And then let's just go ahead and close this up. And Apex went ahead and just deleted that remaining edge because it understood that edge did not belong to anything. It was not connected to any other edges. So it went ahead and deleted it for us. Close out. Back to shaded. Zoom out. Now use our filler tool. Fill this back in. And let's go ahead and mesh our solid. Change our mesh size to 0.2. Again, using all the other default settings. Okay. Even turn off our geometry. See, we got a pretty nice mesh for just, again, using the default settings in Apex. You see something a little strange in this corner. Let's go ahead and turn back on our geometry. Zoom in. We see we have some kind of weird polygon face here. And we also have one on the other side as well. Possibly something happened with the fillet tool. And to verify that it's not our mesh, let's go ahead and press our mesh. And yeah, we see that it's still there on our geometry. Go back into our mesh. Go to our geometry edit tools. Key feature. Click on this top face. And we can see that Apex does a local remesh. It goes ahead and just remeshes this localized area where we just deleted that polygon. Same with this. Okay. Now we see that Apex actually went ahead and once those strange features were gone, recognized this as a cylinder and put a nice uniform mesh on our cylinder face for us. Also, if we wanted to come back and make changes to our mesh, rather than remeshing, we can right click on our mesh, go to Properties, and we can even change this from 0.2 inches to 1/10 of an inch. Click Apply. Now we can see we have really nice mesh density on our model, and our cylinder face looks even better. Okay. So in summary, I have showed you how to use Apex Modeler to find problem areas, correct these problems either automatically or manually, modify geometry such as deleting fillets and pulling faces, meshing both solid bodies as well as solid faces, and then exporting geometry and finite element data to continue the analysis in MSC Patran. If you have any questions about MSC APEX, you can email me at austin.pizzella@esacorp.com. For general questions about ESA, you can contact Martin Martinez at martin.a.martinez@esacorp.com. You can also visit our website at esacorp.com. And this is a re-recording of my original presentation given on February 12th, at the end of which there were no questions from the viewers. If you have any questions, please feel free to email me. Thank you for joining us, and we hope you will tune in again for future sessions of ESA's Afternoon Technology Series. Thank you.